Okay, so for this method, we're going to call these equations. By the way, this is a 3 by 3 system. What that means is three variables, x, y, and z, three equations, all part of one system, right? So this looks pretty daunting to start with. You're like, oh man, this is a lot. So I'm just going to call these names to begin with. So this is the equation E1, this is E sub 2, and this is E sub 3. So just so we can kind of keep our work organized, because it's kind of it's hard to keep track of what you're doing, and this might help us kind of keep organized and stuff. Okay. So the first thing I might consider doing is just write the steps off to the side. So step one, using this method, is to pick any two equations. So pick any two equations and get rid of and eliminate one variable. Eliminate one variable. Okay, so like right away, I'm just trying to pick the easiest one. I see equation 1 and 2. One has a negative 2y, one has a positive 2y. If I add those together, I think that will work out really nicely for us. So I'm going to do that. So I'm going to say E1 plus E2 are my two equations. I just tell you what I'm going to do on the front end. Okay, so we're going to add those two up. So I'm going to take the x minus 2y, that's a minus there, plus 3z equals 1, and then the x plus 2y minus z equals 13. Just going to add those up. When I add them, I get 2x. I get plus 2z, that the y's go away, equals 14. Okay, so first step, I now have that done. Okay, so step two, pick two other equations. And what I mean by other equations here is any other combination. So I picked 1 and 2, so you could pick 2 and 3, or 1 and 3, and eliminate the same variable you did in the previous one. So we chose to eliminate y, the same variable. So I have to choose two other equations and eliminate the same variable. So I'm going to choose. It seems like E1 and E3 would be good choices here. So E1 and E3, if you look at the y's, they're negative 2y and 2y. Again, I just have to add. This is like just a piece of cake here. So let's do this one in green. Okay, so we've got this one will be E1 plus E sub 3. Let's do that work down here. So this would be x minus 2y plus 3z equals 1. And equation 3 is 3x plus 2y. It's going to work out nicely. Minus 5z equals 3. It's really important just to keep your eyes like focused and so many different equations. Just write down the right equations. We're just going to add those because the y's are going to go away. So we add those, we get 4x minus 2z equals 4. So what we have here right now is we have this equation, and this is the resulting equation there. So, which is really helpful to know. Okay, so we've got, so step 3 is solve the 2 by 2 equation, 2 by 2. So you see that's a 2 by 2. We have x and z, got two equations, two unknowns. That's the kind of stuff you can do in your sleep, right? We've done this quite a bit. So now I'm just taking these two guys and we're going to put those together and solve them. So I'm going to multiply the first one by, we can just add them, right? Because the z's will go away. I was going to multiply the first one by negative 2 and get rid of the x. But if we just add those up, so if I do that, I get 2x plus 2z equals 14. And 4x minus 2z equals 4. If I add those up, I get 6x equals 18, divided by 6, and I got x equals 3. And we're not done. Technically, we're a third of the way done for this one problem. Actually, we're more than that. We've done the hard work now at this point. The last couple steps here is find the other two, but that's just like plugging other two variables. So in other words, like we've got this equation here, like that's going to be part of our answer here, but we got to plug in to say maybe x right there. So let's try that. So we get 2 times 3 plus 2z, just like you would in any 2 by 2, equals 14. So I get 6 plus 2z equals 14. Subtract 6, so I get 2z equals 8. Divide by 2, you get z equals 4. We're 2/3 of the way done. Now we know z. And then you've got to plug into one of the original equations over here. So we're going to choose this one. We're going to plug in an x value of 3 right there and a z value of 4 right there. So let's do that. So we get 3 minus 2y plus 3 times 4 equals 1. So this is going to be, see, 3 plus 12 is 15, so I get negative 2y plus 15 equals 1. Negative 2y equals negative 14, and then divide by negative 2, y equals positive 7 there. Okay, so we have our three answers. Make sure that your answer in the form, like it might be A, B, C, put them alphabetical, X, Y, Z, whatever the variables are, put them alphabetical. If we want to, it's kind of like an ordered pair that's a triple ordered pair kind of thing. It's just, it's three-dimensional, so to speak. So the answer is going to be 3, comma, 7, comma, 4. I want it written in that form, just like it is. This whole chapter, we want our answers in ordered pairs, in this case, and an ordered triple kind of thing. And that's how you solve it. And if I plug those into any of the equations, if you want to check your work, it'll make the equation true. So I could plug in x value of 3 here, y value of 7, z value of 4, and it would solve it there just fine. Okay, let's try that again with a new system here. So we're going to try this. I might shortcut in this a little bit. Sometimes I like to do a little shortcutting here just because it's such a kind of a long process to do. Okay, so let's look at it first and decide which one seems like an easy one to get rid of. In this case, I think y seems pretty easy. So I see that in the first two equations, if I just do a little, so I'm going to do this. I'm going to do e1 plus, I'm going to multiply the second equation by negative 1. And that should get rid of the y variable there. So let's try that. So this will be x plus 2y minus 2z equals 1. Now multiplying the second equation by negative, so I get negative 2x minus 2y plus z equals negative 6. You notice I changed the sign of everything there. We're going to add those together now. Okay, so we get negative x, and then the y's go away, minus z equals negative 5. Okay, now we're going to choose two other equations and eliminate the same variable, in this case y. So I'm going to choose the second two equations. So I'm going to do so e2 and e3. So I'm going to multiply e2 times negative 2 and add just plain old e3 here. We could have gone different ways there, but this seems okay. So the first equation there is going to be negative 4x minus 4y. See, negative 2 times negative z is plus 2z. then negative 12. That's a negative there. And then this is going to be 3x plus 4y, that's nice, minus 3z equals 5. We're going to add those up. So we get negative x minus z equals negative 7. Okay, at this point, we now have a system, a 2x2 system that we just created. Right, so we're going to now solve this. Over here. So we're going to, let's see. Oh, wow, this one really, it's going to be interesting what happens here. Okay, so we're going to multiply the first equation there by a negative. So I get x plus z equals positive 5. Second equation, I'm just going to leave as is. Negative x minus z, something interesting is going to happen here, equals negative 7. So I didn't change anything about the second equation, but I did multiply the first equation by negative 1 there. So that whole thing was multiplied by negative 1. Okay, I'm going to add. I get, well, 0 on the left-hand side and negative 2. Does 0 equal negative 2? It does not. Therefore, there is no solution here. So that's going to happen sometimes in these problems. If I got something like 0 equals 0 or 2 equals 2, it would be infinite solutions. So that's always a possibility that you get those kinds of answers there for sure. Okay, let's try this one. So we're going to, say E1, just so we can kind of talk about it, organize our work, E2 and E3. Okay, so which one do we want to get rid of? This is terrible, but it just seems like Y is the easy choice here. So I'm going to do E1 plus E2. So that's what you want to do. You want to choose the easiest choice, E1 plus E2. Sometimes I'll do this. Now that you're getting a little better at this, since I'm not doing any arithmetic to this, I'm just adding them. I'm just going to write the answer here. So I'm not going to show the problem. So x plus 2x is 3x. Y plus negative y is 0. 5 plus 4 is plus 9z. And negative 2 plus 2 is 0. So I've already got my first equation of the 2x2 there. Okay, let's try the next one here. So we've got to pick two other equations and get rid of the y. So how about we pick 4 times e1 plus e3. So that should work. So I'm going to do 4 times e1 is 4x. Because I'm doing an extra term, I am going to probably write it out this time. Minus 4y plus 20z equals negative 8. And then the third equation is 2x plus 4y minus 2z equals 8. Okay, so this one's going to be 6x plus 18z equals 0. Okay, so now I have a system of two equations with two unknowns. That's going to be a piece of cake to solve, hopefully. So we're going to multiply that first one by negative 2. So if we do that by negative 2, we get negative 6x minus 18z equals 0. And the second equation would be 6x minus 18z equals 0, or sorry, plus 18z. Yeah. Okay, if I add those together, wow, I get 0 equals 0, which means there's an infinite number of solutions. By the way, your book may give you other answers in this, but I want you to say infinite solutions. There's a pre-cal method of finding that actual line it's on, but it's an okay answer to just say infinite solutions at this point. When all the variables disappear and you get like 2 equals 2, etc., that's going to be an acceptable answer. This one, it should be easier than the other ones we've done, but sometimes students have trouble with it. So The reason it should be easier is because to me, when I look at this, I've already got the first equation of a 2 by 2 right there. So I'm going to skip a step here. So I don't need to even involve I don't need to involve equation really 1, 2 at all. So it's almost like I've got E1 and E3. I've got to like do something to those to get rid of X, but I've already got my other equation. So to me, I always pick whatever one's disappeared. I'm going to use my other two equations to get rid of that same variable. So this should be an easier problem. Sometimes you just have more trouble with this one than just a 3 by 3. This is a almost a 3 by 3. It just doesn't have an X there. Okay, so so let's see if we do -1 times E1 plus E3, oops, E3, that should get the variable to go away. So we get -X plus Y minus Z equals 0. And then E3 would be X plus Y minus Z equals 2. Okay, if I add those, I get 2Y minus 2Z equals 2. Okay, so I have my second equation here. Now I have two variables, two equations. Okay, so I get, let's see, let's multiply this one by, oh no, we're going to have to multiply. We need to add these things, right? So I'm just going to add them. So I'm not going to show my work because those two, if I add them, it should just, I don't have to adjust anything. So 3y, the z go away equals 0. Divide by 3, divide by 3, so y equals 0. Okay, so I'm a third of the way there. I've just plugged that back into this, see what I get here. So this will be 0 plus 2z, 2z equals -2. So divide by 2, divide by 2, get z equals -1. 2/3 of the way there. Plug back into maybe this equation. If we do that, we don't know x, it'd be x minus 0 plus -1 equals 0. So x equals 1. Okay, so my solution is 1, comma, 0, comma, -1. Got it. If you're not sure, you could always plug that back into, say, the third equation or the second equation or the first equation, make sure it works in all three, and you can see you have yourself a solution. So that's the basic Gaussian method here. Enjoy the homework. It's intimidating. Each problem does take a little bit of time, but actually once you get good at this, it's just like, just a little extra steps to solving a 2 by 2 system.